Welcome everybody to this edition of our Cassandra Community webinar series. I am delighted today to introduce Patrick Mcfadden. He is the Chief Evangelist for the Apache Cassandra community here at DataStax. And Patrick, this is the third in his data modeling series. You know, we hear from so many people in the community that getting your head around data modeling is really a prerequisite to being successful with your application on Cassandra. So in this webinar, Patrick will just recap some of the fundamentals around data modeling, and then by the end of the webinar, you will really be in good shape as you move forward. And as always with our community webinars, we will be reserving Q&A until the end. Please use the WebEx Q&A panel and post your question there. We will reserve time. I will read through them, and we will get through just as many questions as we can in the time allotted. So without further ado, I will hand everything over to Patrick. Welcome, Patrick.
Am I unmuted? Oh, now I'm unmuted.
We can hear you loudly and clearly.
Good. Yeah, no, unmuting is good for me. I think it's good for everyone that's on the webinar, too. All right. Well, this is, I'm not going to do that slide just yet. You can go back to that one later, Christian. All right. I'm having trouble.
Okay, so you should have the ball, Patrick. Whatever you change, we should see.
Got it. Okay. So we have, this is the third part of the series, so let's get into where we were. So the first part of the series was the data model is dead, long live the data model, and it was really about just bridging that knowledge gap between relational database world and Cassandra. It was all about really it's a concept and trying to help you get through some of those concepts. Always a requirement because I talk to people all the time. We've learned relational databases. We as a community, we as a technical people have learned relational databases for years and years. And there's just some ingrained knowledge. How can we use that knowledge instead of replacing it, augment it, and get to this newer type of technology that will give us things that we want that maybe a relational database won't? And then the second was the become a supermodeler. That's when we really get into the hardcore part of data modeling. And it's all about CQL, and that's a standard query language. I really wanted to use that as it's just the only CQL discussion and give you some really good tools, some more advanced features, some good topics around that. So what we're going to do this time is, now that we've got our background, our foundation set, I'm going to walk you through some real-world examples. I work pretty exclusively with customers, and I get to see what people want to do, and I've learned a lot about some of the more common use cases. And I'm an engineer. I learn from examples pretty easily. I think that's a really great way to learn, and I hope that you guys can do the same thing. So here we go. Why are we doing this? Why are we even talking about data modeling? So the data modeling Cassandra, in my opinion, is the path to a good time with Cassandra. So whenever Cassandra data models are created, they're all about your application. I do not care as much about the data as I do about your application. And I say that a lot because the application really is the important thing. You're not building data. You're building an application that will store data. You need a persistence tier that will work the way you want it to work. So that's why I always take Cassandra data modeling from the application tier. What are we doing there? So it doesn't work for every single use case. And that's okay because it's not, I don't think we're in a world now that we should say there's only one solution. I've said this in my previous webinars, polyglot persistence. It is true. You've got to have that now. In this, we got different ways to store data. If you're going to do search you're probably not going to use something like Membase or Memcache because it's a key value store. You're probably going to use something like Solr, which does search really well. So, you know, those are extreme values on different ends of the scale. Cassandra covers a lot of topics and a lot of different use cases, but you got to make sure you can use the right ones. So when it comes down to those two things, you get a choice. You got to make the proper use case with the proper model, and that's my thing here to winning. And you will win if you get this right. And if you don't, well, that's where the sad panda comes in. And you don't want to be the sad panda. You want to get it right the first time. Nothing sucks more than having to re-architect your solution because you didn't get it right the first time. And so what I'm going to do is show you some of these. So when to use Cassandra. Boy, do I hear that a lot. Actually, I hear the opposite a lot more too, which is when not to use Cassandra. There's, you know, there's both ends of that. So let's talk about this a bit. The when to use Cassandra is, I go to like its core strength. It is very good at replicating data. Cassandra at its base is very good at making sure your data is available across data centers, inside one data center. It's hard to kill Cassandra, where we've lived in a world of single points of failure, and everyone preaches a good word of don't use a single point of failure. Well, all right, we don't want to use that. Use Cassandra. And when you need to scale, scaling is another issue that is difficult in a single point, like if one database or one database server usually means scaling it up and building up a bigger server, one bigger server. I prefer to work with things that are horizontally scalable anymore. I mean, it's 2013. I'm sure now that just data just talked, but we shouldn't have to worry about things vertically scaling anymore. So whenever you use Cassandra, you get horizontal scaling, but you don't really know what the scale is going to be today or tomorrow, the next day. You know, you have question marks about how far it's going to go. It's great for that. Cassandra is linear scaling. You need 10% more load for your application, add 10% more servers. It's just that easy. And the Uptime Guarantees. I've worked in engineering, like I said, a long time, and I always got the question is like, how do we get 5 nines of uptime? Well, you just start adding zeros, right? And that doesn't really work for a lot of people because then they don't have the budget. So you need to find something that will get there without having to cost all those zeros. And so Cassandra is really good for people that want to have close to 100% uptime. And I say close because I'm a realist. Things happen, right? But you shouldn't have things like maintenance periods or maintenance windows that interrupt your uptime. You should be able to take down a server without bringing down your entire cluster. And in all of that, getting to any of these solutions costing just enormous amounts of money. And you know, we're all cost conscious. We always have to be. I don't know anybody that says, hey, my IT budget's unlimited. It just doesn't happen. You're going to have boundaries on how much you can spend on things, and I've been involved in this too many times where we've had to make really bad decisions because of money. Like, yeah, we'd really like to have close to 100% uptime, but we can't afford to put it into 2 data centers or something like that. So it's sad whenever you have to make that decision. So it gives you more abilities and then it doesn't cost as much. So, you know, Oracle, and it's my saying I'd say a lot, is that Oracle scales right up until you run out of money. And that's pretty bad when that happens. So these, I put a little asterisk on there. There's a lot of ors and ands in this. There's, I mean, these are all ors and not ands. So it doesn't have to be, all of these have to be true. And there's caveats on everything, but this is a pretty good list. So you have to get the data model right. And that's why you're here. Data model is everything because it's going to express the way you want to use Cassandra directly with the data model. That's how we're expressing. Mine using Cassandra this way, here's how I'm going to use it. So here's my 4 examples that I'm going to present today are they're real world. And they are, I should say, expressions of the real world. And I put in here, you think it might be you. If I gave this talk, and I actually called out somebody that it was them, but these are generalized cases. I hear these all the time, and that's probably why I use them. But I want to make sure you have something that's generally useful, but also very specific as well. What I'm going to present is really just the use case. Like, this is what they're trying to accomplish, and here's how we did it. Here's the model. And everything that I'm going to show you is in CQL3. CQL3 is really the path forward for Cassandra. And if you look at our drivers, and I really encourage you to go out and check out the DataStax drivers. We have C#, Java, Python, more coming. And all of these drivers use the same methodologies. And CQL is the core for all of them. Go out and download them. They'll make your life a lot easier. And it's just a joy to work with these. I think if you come from maybe 2 years back, say, or a year back, using Cassandra was a lot more difficult whenever you did programming. It makes it a lot easier. And I really like working with them. So let's go through some comments here about CQL. And I got this, CQL doesn't do dynamic rows. I hear that all the time. And yeah, they do. So this is just my Mythbuster slide. Just make sure I just keep reiterating this point. But CQL does do a wide row, meaning what we've always talked about in Cassandra, where you have a row with a lot of columns, and that's a really good data model, and you don't want to make things too tight. CQL makes it look like that you don't get a really wide row anymore. It looks like it's turning it more into like a relational database. That's not really the case. It's really an abstraction of what's really, we're doing best practices under the hood, and it's an abstraction layer. I encourage you to go check out the blog post on here. My slides are up online on SlideShare. You can go check these out. So you have an actual clickable link here. So Jonathan Ellis is the one who did this blog post. I put like a really huge comment after he did his blog post at the end, kind of doing it more. I added more to it. So read Jonathan's blog post and then read my, I don't know what you would call it, an addendum in the comment that I put in there. Is just actually answering a question that somebody had. But this is a big deal for me because I really want people to understand it. I'm not just telling you to hit the I believe button. I want you to go do it and look at it and understand it. So I put some examples of how you can just do it yourself and look and see the data on the disk and see how it looks. So I just trust me. Well, in this case, I mean, you're not going to run off and go do this, and maybe you will if you're watching this on the recorded version, but just trust that this is the case for now. You can go verify it later, but this is how we're going to make it work. Okay, so my first model, shopping cart. And I think the shopping cart model is great because there's a good example of, hey, I need as close to 100% uptime as possible. Because think about that. That's people giving you money, and you do not want to lose that. And you want it to be online all the time because people giving you money is the reason probably why you're in business. So what's the use case? The reliability of that shopping cart is critical. You have to know that that data is getting stored. That if people put, and I mean, I've seen this happen. You put something in a shopping cart, something happens that redirects you to the home page, and then everything in that shopping cart is gone. It never happened. It never happens as much anymore. But when it does happen, you don't want to go back and re-look for stuff and have to redo your shopping cart. How many times are you just going to walk away from it? You do not want to present your customers with that choice of just walk away when they had money sitting in the shopping cart. Downtime and minimizing that downtime means multiple data centers. You cannot be serious about your uptime until you start talking about multiple data centers. And it's just a fact of life because data centers go down. They will go down. May not today, maybe not next year, but they will eventually. And if they don't, your other data center will probably go down. So just doing multi-data center is how you can get the most and the best high availability. So Cyber Monday is now in our vernacular. it used to be the Black Friday, that's when people would kill each other to go into a store after Thanksgiving. In the U.S., Thanksgiving is in November, and so there's all these Christmas shopping things. It's really kind of a problem that has more of a generalized case now. The other thing you would call it is a thundering herd problem, where all of a sudden all your customers show up at the same time. Cyber Monday is in the U.S. is a problem with the Monday after the weekend of Black Friday. All the online shoppers show up at the same time. Well, you want to be ready for that. You want to be able to scale. Let's say your load is X, and if you want to do X plus 50% or X plus 100%, be ready for that. Because the last thing you want to do is, again, leave all that money on the floor. So what you're going to get out of this from the bad side, and this is what your boss is going to tell you, is we cannot be offline for a minute because that's money. And so you don't want to tell your boss we're offline for a while. There goes all your money. And online shoppers are all about speed as well. If a site starts to lag, that's bad. We do not want your site to lag if you have that X plus 100%. So thinking about scale in that way is really important. So how do we do this? So I got my little whiteboard here showing how we're going to do this. So each customer can have one or more shopping carts. Now, the or more is kind of cool. I've done this at a couple websites. I think it's more common now. But if you want to keep a couple of shopping carts going, and so you want to be able to store that, we're going to denormalize all the data so it's for fast access. So thinking back to my other data modeling discussions, you want to go with the row key. The key is your fast access. And then denormalizing that data into a single path and making it all part of one row, that makes it fast. It's fast access. So we have one shopping cart, one partition of data. That's row-level isolation. So that gives you the ability to update that cart from multiple sources and make sure you never get a dirty read out of it either. So that's our row-level isolation that's already in Cassandra. So that will save you from some embarrassing moments where you might have half a shopping cart show up in somebody's inbox. That's not going to work for anybody. And so now with this model, you can see that each new item will be a new column. So dynamic. It will grow out however many columns it needs to based on how many items that you have that you want to put in there. And that makes sense. That fits into the application model where I may want to order one thing or 10 things or 100 things. It shouldn't be limited by some sort of hard limit like how big an array is or something. So what we're going to do here is we're going to use a couple of cool techniques. And so my first table is going to be my user table. And it's going to have, the data model is pretty standard, but we're adding this extra element, which is the shopping cart, shopping carts, I should say, with a set. So a set, if you recall, is a collection that's available in CQL. Really cool method of gathering random bits of data inside your static model. And that set is going to contain, and now I put this example over here on the right, where I have this set that shows all the stuff that I've put in my shopping cart, and I could denormalize that if I wanted to. But in this case, I just put in a bunch of information about my shopping cart. Now, what about, or like a list of shopping carts in this case, like what I have in there. This is another thing you can use if you want to do that. Now, the shopping cart itself is really where all the juice is. So I have a list of all these shopping carts. Now this is where the wide row comes in. Now if you look at my, on the right where the example is, sorry, both of these are shopping carts, my bad. If you look at when you're inserting data into the shopping cart, it's really dynamic. And it's showing all kinds of interesting information in there. But I also put in item details where I've used a map to do that. So different items are going to have different details. Like a book will have pages, maybe, or something that has weight, or something that has dimensions. Not everything, if you order an e-book, then it's going to have so many pages and it's going to be so many kilobytes of size, but it's not going to have any dimensions. But if you order something physical, say like a skateboard, it's going to be so long and it's going to be so tall and it's going to weigh so much to ship. So these are all individual details of each item that you can store dynamically inside your shopping cart. Now, why you would store it there is you're just denormalizing at this point, and it just makes it easier. You're bringing that data in that's relevant. So whenever the shopping cart gets to the checkout phase, maybe there's some information in there that helps figure out, like, say, shipping costs or like how it can be delivered or anything like that. So take this model, and you can see now, how it can be done, but you can also mix and match on how you want to make yours. What's cool about this is it's very flexible, but it's also very available. I can have this running in multiple data centers, active, and this is very simple enough to do that. Okay, the next one is our activity tracking. This one is a little bit freaky, but I like it. And I've seen this in a couple places where storing data about customer interaction. So we have this need to react or to act in real time.
Just to let you know, one of the viewers has asked if we can zoom in on the slides. So if you could go full screen, that'd be great.
Sure. Like that?
Perfecto, sir. Thank you very much indeed.
Yeah, does that work?
Yeah, and just to everybody, if you want to then ask a question, just mouse over at the top of your screen, and you'll get a little toolbar, because sometimes it's a little tough to find, and ask us any questions in the Q&A panel. Thanks a lot, Patrick.
All right. Sorry if that wasn't very viewable. We try to be interactive here in real time. Oh, yeah, well, I was talking about real time. Right, so user activity. And there you go. Now I'm reacting to user input. Good segue. Thanks, Christian. So the user input, you do need to react to in real time. You can't wait. And so many times where I've heard people say, I'm going to use Hadoop to do that. Well, all right, you're going to get that tomorrow. So that's the bad, right? Waiting for batch. And getting input and then dealing with it is really critical in today's world. Support for multiple application pods. The application pod is more of a design architecture concept, but really it's all about building out your application so that everything you can deploy it into parts. And I will show you in my slides in a minute here what that looks like. And then speed is always important. And if you're reacting to something in real time, you need to be able to do it in milliseconds. Humans tend to notice things that are over 200 milliseconds or about 150 milliseconds. So when you start reacting much slower, it starts to become very apparent to the end user. So let's try to work that into the budget for time and react in that time. So the too bad, I mentioned the batch, which is, if you got to have now, Hadoop is not the choice. It's just not going to do what you need to do now. You have to have another plan. And losing those interactions when you have somebody on your website, say they're in that shopping cart, or they're doing something on your website you want to react to that can potentially give you more lift or give you more money, then you need to interact with them now. And so how do you plan that out and do it? So my activity model, data model, is somewhat different. This is more of a flow diagram sort of thing where, so the interactions are stored per user in a very short table. So let's say if someone logs into the website, we have a decision engine that can make things happen. And so as things are happening, we can take these long-term interactions and store them later, but then we can also interact with them now and make decisions. So like when they log in, and then we have something like an A/B choice, so they can go either to an A page or a B page. Well, the feedback is going to be whenever you log into the page, we could store what this person has and what their next destination will be. Maybe based on this user profile, we want them to go to a different web page. Maybe it's something that they did. The interaction decision algorithm will say, well, based on the last few things you did, we're going to send you to web page B instead. And then we'll get some feedback on that. Did that make them buy something, or did that give them, did that keep them on the website just a little bit longer? So that's the kind of freaky part about this, which is cool and creepy at the same time, which is we're kind of getting into people's heads a little bit. But that can only be done if you're doing this in real time. I've done a lot of data mining and data science stuff on previous interactions. They're cool, but they just don't have the same kind of impact as real time, like what I'm talking about here. So one of the other things we're going to do is store these in long term so we can create feedback. There's still cases for Hadoop. There's still cases for a long-term batch analysis, and that's to validate our models and things like that. We'll still store that data. And then we're going to use a reverse time series. Reverse time series is one of my favorite little time series tricks, and we're going to look at that. So I have my user activity table, and this is the one that stores that interaction as we go through getting the data. Now, it's just as someone's clicking on web pages. So basically, we put a widget or something like that in the web page whenever they click to the next page, blah, 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 that we're tracking that interaction, that was going into the user activity table. So the user activity table is going to have who they are, the time, what kind of activity they did, some details if we want to put that in there. But if you'll notice, I put a reverse order on based on the timestamp. So this clustering order by, and that means I'm going to reverse this row based on the interaction time. When you reverse a row like that, what you're saying is the last thing that happened is the first thing on that row. Very efficient. Because when I go to ask for that data, it will be right there. We don't have to do a big seek on the disk. And I'm going to show you what I mean in a minute here. So when I insert data, here's my login. You can see on the right, the very first top right, where it says user activity. I'm inserting who it is, my interaction time, which is a time UUID, which gives you microsecond resolution, and it's a normal login. But then at the end, I'm putting a TTL of 30 days, meaning that column will expire after 30 days. So I'm really just keeping a 30-day window of those interactions, which is totally cool. And I will work around that because the next table I have is my user activity history. Again, same type of data. I'm collecting about who they are, where they went, but I'm changing the data model a little bit. And I'm going to make it so that the username and interaction date are the partition key. And the time is not reversed. It's in a natural order. Everything else is pretty much the same. When I insert that data, I'm not going to try to expire it. This is permanent, so to speak. It's going to be history. So this is a great way to store long tail data. So what I want to point out here is when someone logs into the website, for instance, we're storing that data in 2 different tables. And that's totally cool. You can do it in 5 different tables, 6 different tables, 10 different tables. And I've done this a lot, where you just get so many you have such good write speed, so you can do multiple writes per second, thousands and thousands, millions potentially on Cassandra, that should not be the limiting factor in your data model. You shouldn't. When I was an Oracle DBA dev, I worried about how much I was inserting into the database at one time. So that is just not a consideration with Cassandra. So think about what are you going to do to lay out your data so you can read it out more effectively. So how I'm going to use this data now, here's an example of why that reverse works so well. Is that if you look at the select from user activity, limit 5, what I'm saying is I only want the last 5 things that happen. I don't want the last 10. I want the last 5, and it doesn't have to go over this massive amount of data to get that data out. It's just going to go over the first 5 items in that row. Very efficient. And if you're running a trace of some sort, you're trying to figure out where your performance is. If you didn't do the reverse and you asked for the last 5 things, you'd be iterating over a ton of data before you got to what you want. Reverse prevents that. So this is fast. This is an interaction pattern that makes it go really fast. So what I've got here is this person they went into the jewelry, they created this anniversary a shopping cart, and then they deleted the gadgets I want. So in my algorithm that I picked, I'm like, ooh, maybe we should put a sale item up for flowers too, because this dude must be in trouble. And so then open up the gadgets I want, and then so wait a minute, hold on. So we created this anniversary gift, and now we're doing jewelry. Awesome. How about some flowers with that? It's kind of my dumb example, but in my opinion, you know, this is the kind of stuff you could do. You just got to come up with what you want to do, and that's when it gets fun, but probably a little more interesting is what do you want to do with that data? Simple or complex? You have the data though, and that's the important thing. My third one is the log collection, and that's probably one I hear probably the most easy because people want to store logs in an efficient way. It's a big problem, and there's just a lot of it. And machines generate a lot of data. We've gotten into this weird, I mean, there's so many cool and scary statistics out there, like, you know, humans have generated more data in the past 5 years than they have in all of history or something. We just love generating data. So we have to store it. Logs, if you're an application developer, I'm sure you've put enough log statements in your code to make it so that you need something like this. So it's always going to be where you need to collect data at a high speed because it's coming at a high speed. If you have 30 application servers in your app tier and they're generating 10, 15, 20 application log events during a single interaction, you could be generating hundreds and hundreds of application logging events in a very short order. So Cassandra will do this in near where the logs are generated, and I think that's when you talk about how we deploy our applications, we're probably going to do it multi-data center. If you're a multi-data center and you're collecting your logs to one data center, you're sending a lot of data over the wire, but it may not be as relevant. So we want to make sure that the application that's generating the data just goes to a local stop and then let Cassandra do the replication for us. The need for dicing the data as well. So classic use for logs is something like a dashboard or a lookup. So we need to come up with, that's our use cases. We need to be able to dice up all that data or put it into a usable form. The bad side of this is that the scale, you know, don't try to do this with your really expensive relational database, and it's just a lot of data that it's going to have to collect. You're going to have to scale that thing to the point where it's not very cost effective. And so there's a better way to do this. The batch analysis of logs is way too late as well too, and that goes back to our previous use case where the data that you're getting now is relevant now. Maybe it's relevant in the next 5 minutes, maybe the next 10 minutes. I can think of many times where I've actually built this system. Years ago I built this system in Cassandra, and it was really so that we could get up to the millisecond information about, say, how many 500 errors we were getting on our website or how many 404s we got after a code push. These are relevant information points that we needed now and not after batch picked it up and gave us a report the next day, because it's usually affecting customers right now. If we're getting, all of a sudden we spiked up and we get a delta on our 500s of, you know, plus 100% in the last 5 minutes, we better start looking at what's going on. And that's some relevant information that we're getting from our logs. So this is what we're going to do. We're going to use Flume in this case. Those of you not familiar with Flume, it's a pretty cool tool it's another Apache project. It's actually a sub-project of Hadoop, but it could stand alone pretty well. It doesn't really need Hadoop. It was invented, I guess, as a way to get logs into Hadoop, but it's found a lot of general purpose ways. I've worked with some teams that use Flume in all kinds of interesting ways, especially dumping data directly into Cassandra. It works really well. It seems to scale in a similar way. So it does these fan-out things, and it can go to different tables. So we're going to use Flume in this case. We have various tables that we're going to set up in Cassandra to log those. Now, what that means is that we're going to have, say, a table for, I put some on here, like just one for the raw logs. So just store the raw logs. I don't really care what format it's in. I just want to have those for the, like if I ever want to do batch analysis on those. And then I have my latest successes and my latest fails. So this is that dicing action I'm talking about. When data comes into Flume, you can look at the event, pick it apart, and start setting up counters or maybe putting that information into a separate table. I wrote an application that for every web event we got, we wrote it out to 90 different column families. And those tables, those 90 different tables, were collecting data for different reasons. Perfectly okay. Cassandra will scale to that for you. And so there's different things that we may want to do with it, like a lookup or a dashboard. Dashboard applications are really cool for that kind of stuff. And you need access to that data in just a short window of time. Great time series model. So here's our log lookup. So I want to look up the raw data in my logs. And let's say I just know I have a time frame or something like that. So here's a case. Let's say we're using an access control device and we want to look up based on the source and the date when we actually collect that data. So I want to look at an event that happened at a certain time. Well, this date event or this table, log lookup table, I'm going to have the source and then the date up to the minute as my partition key. That will make sure that I have a nice partition of data. It's not collecting tons and tons of data all in one row, but I can get to it because I have one of the keys that I found to creating the queries and putting data into a table is using data that you have. You're going to have a timestamp on that data. Use that data to create your keys. Use that data to create the actual columns. You don't have to derive anything. You just use the data you have. And then it's natural, too, on the other side, if I'm looking up data, I'm saying, hey, everything from this one access controller, I want to know everything that happened at this certain time to that certain time. So from a range of dates. Awesome, you can do that. Now what's interesting is we have this blob of data, this raw log. Here's my ninja trick. Everybody should pay attention to this because I've seen this in great effect. If you're storing any kind of raw log or even something that doesn't need to have, you don't need to get insight into, you just need to store something in bulk, like even JSON or XML, gzip it at your application. Compress it at your application before you send it over the wire. Great idea because you're minimizing the amount of data that you're putting on the wire. That's a good thing. But it's also more efficient on the Cassandra side. You're just going to store data. I mean, you're storing data to retrieve later. There's almost no cost to zip it. I mean, you were talking microseconds to gzip, a reasonable size object. So just use that. On this, we were also storing that exact same web event into two other column families, two other tables. So if you look to the right, I have my login success. Now, what I'm doing with that is, so like, let's say this access controller, I keep the source, which access controller it is. I use the date up to the minute as the one of the partition keys, but I'm using that to create a wide row. And then my successful logins, I use as the counter. So this is the counter column. What I'm doing, if you notice again, like I said, it's one of my favorite tricks with time series data models, is clustering order by. Reversing the clustering so that you get that last object as the first one on there. Here you go. This is where the dashboard comes in. This is going to be awesome because what you're going to get out of that is I'm going to ask for the last 10 things, or I want everything within a time frame. But usually it's going to be the last 10 things. Think about a dashboard where here's my select. I'm going to select up to this minute successful logins, and I'm going to limit 20. So I'm grabbing the last 20 seconds worth of stuff because I know I'm 20 minutes worth of stuff because I'm collecting it by the minute. So here's my counter. This is really fast because I'm going to be able to I have the exact row key, and it's a very small slice of data. It's only 20 items, but it's pre-optimized. It's ready to go for this dashboard. Very cool way to do this. So in this case, I'm looking at, here's my successful logins, they're going up. All of a sudden they start going down and my logins, my failed logins are going up. Maybe I haven't access, my LDAP server on the back end isn't working, or maybe one of my access controllers isn't working very well. But this is relevant information right now. If I had to find that out from a report tomorrow, I'd still have a whole bunch of users not very happy with me. So this is the kind of stuff that you want to know about and react to it immediately. This is real-time, the need for real-time data. Last one is user form versioning, and that was one that I called out. But I think this is a little different, definitely not as mainstream, but gives you a bunch of interesting ways to model your data. So here's an actual real, I had a couple places to do this, but a real need for this, user form versioning and be able to roll back. So I have a form, a user form on my website, and I want to store every one of those versions efficiently. And I mentioned this before, and I think it's funny, is that I do not expect people like admins in the front office to learn how to use Git. I mean, can you imagine that? It just wouldn't work. I think that there's that kind of functionality that you may need to present to them, but you need to find a way to do it a little better. And that's where we probably can get a little more creative with our data model. So, and the scale is really important. If we have a lot of users on our websites, let's say you're creating web forms for users and they can use them on their website, it's got to be able to scale. And that's where things that like version control issues and locking and this turns into a real problem at scale. And the other really critical thing is you need to be able to say commit a change, but then more importantly roll it back. You need to say, oh, that was bad change, I'm going to take it back to a previous version. So you need to have the way to scroll up and down the versions. So in a relational database, it is a very complicated relationship model, and this is probably one of those times where the relational model breaks down. It's just so complicated to do a join in these cases. It becomes prohibitive in a way. It's very complex and very slow. We'll look at our data model why it's a little more simplistic whenever you look at it from a denormalized sense. And the other thing is that it has to be this particular customer has a local data center and then a cloud presence as well. Doing that with a single, like an Oracle, is very difficult, because how do you replicate that data, and especially how do you get it to work in the cloud and your local data center in a way that there's parity. So here's our data model. So each user has a form. They just own a form, and every version gets created. So and we'll reverse that so that the latest version is the one that's sitting right next to their, is the first thing on their row. But we can keep a dynamic version. So every time they create a version, it just goes out. And we'll use a separate table to store the live version, meaning we just have all the attributes for the current working version. So what we can do is create that data. That data will be used by our application to create the forms on the web page. But if we ever need to change it, we can just roll back to a certain version number inside their form table. And the other thing is we need to have this business of an exclusive lock. So how do we do that? Ooh, did I say lock? I did. So a working version is our table that we're going to use for our forms. And most of this is pretty basic. You have a username and a form ID, which creates the partition key, and then a version number. A version number will make it so that every one of these attributes is then locked into a particular partition, a CQL partition. So it'll look like a row of data when you look at it in CQL. But the created, the locked by is how we're going to make sure that we only have one user doing this at a time. And then the form attributes map is where all the real business is. That's a very cool use of the map, so you have a key value pair inside of your working version that's locked by a version number. So if you look at my inserting of my first version, so the working version that I'm creating is this version 1 of the application, and you'll see that it's my username and my form ID. And then I have it's just a map of all the different things. I have a first name that's text, and I'm going to have the label for it, and the last name is text, the email, a newsletter that's a radio button, and then here's my choices. So, like I said, this is a real example. This was used. This is probably out there. You can probably find it, I bet. But I've also added this clustering order by. So whenever I create new versions, I'm actually using the version number and reversing it. This is similar to what we did with the time series model, but with the version number, because it's a natural integer, I think I made it an integer, didn't I? Yes, I made it an integer. So it'll do natural ordering if I don't reverse it. If I reverse it, then it'll be the highest number will be the first thing on the row, which is kind of what we want. We want the older versions to start trailing off and then have the current latest version right there. So how do I do this? So when I insert my first version, and that's in the system. Now whenever I start editing it, so for me, this is an application concept, and so what happens whenever someone logs into my site, or they log in, they say, okay, I'm going to work on that form. When they click on that, we just do a single write. We say locked by this person, and I'm going to do an update where username equals Mcfadden, the form ID equals 1138, and I have a particular version that I'm locking, and that's cool. That's what I would call an optimistic lock. It doesn't have to be deterministic, but from a website, that works pretty well because you're only going to have 2 or 3 people probably working on the form, if ever, and you just need to know if someone's doing it. So whenever you go to edit a form, you can see if there is anybody that lock by is even filled. Now, so what happens whenever you insert a new version? So you want to put in version 2. Well, now what we can do to quote-unquote release the lock is just nullify that number. So, or that name, that lock by. So whenever you, in one pass, you're pretty much releasing the lock. You insert your new data and take out the lock. It just doesn't exist anymore. And so then, yes, this is kind of a poor man's lock, but it's really accomplishing what we're hoping is that we just want one person working on this form at once. This isn't like a transactional lock in a database. This is more of just a user lock, like keeping one person out from getting another. A later webinar, when we start talking about 2.0 features, I will further enhance this using our CAS functionality and compare and set. And that is probably a good use for this whenever you want to get better transaction quality if you're really being paranoid about it, like having multiple users going against it at the same time. That functionality was designed around this problem. So stay tuned for that. So there you go. We saw our 4 data models, and there's Master Yoda. He's a data model. People don't know that. He's not only pretty good with the lightsaber and dudes running through a swamp, but he's also really good at data modeling. And so this is important stuff to think about whenever you're creating your data models. It's like, okay, these are all good use cases. This is how I walk through the process. This is not meant to turn you into an absolute ninja, but you're on your way, I hope. And I know that people have watched some of my what I've seen out of people now, you know, especially with groups that I work with, when they watch data modeling stuff, they're starting to really get some great use cases out there. So I hope someday I'll do more of these, and they'll be your use cases. And I think, yes, that's about it. So you can always, you know, get with me. I have a lot of people that get with me on Twitter about various things. Awesome. I'm on there all the time. If you follow me there, you'll see my tweets going like crazy. And I usually talk about this kind of stuff, either data modeling or I talk about Cassandra mostly on Twitter. So just follow me there. If you have questions, ask me there. We might have to get an email, get into IRC, do user group. I mean, there is a very strong community out there willing and ready to help you. So please, let's do that. And I would hope that everybody, you know, takes this and does what they can to make their own data model really cool. So I think that's it. Christian, we need to do some questions, eh?
We sure do. We have 11 minutes. Let's see how many we can get through pretty quickly. Here's one from Tom. Oh, Paige blew it. She took it away from me. I was on the cusp. Tom, can order by be used for any column in the primary key? For example, primary key columns A, B, C. Can I set the order by on just column C?
You have to have a column A and B first, though, before you can do a column C order by. I believe that's the rule set for that. So you have to specify A and B as an equal at least.
Okay, great. I love questions I can answer. Here is one for me. So many people asking about getting access to the slides and the recording. We always send out to everyone who is registered for the webinar the slides and the recording in about 24 hours. So stand by for that. Also, people asking where they can view Patrick's first two webinars on data modeling. Go to Planet Cassandra, hit the Learn tab, and webinars, and we have all the recordings there. So this one definitely teed up for you, Patrick. Regarding CQL query, is there a good Java client to use? Hector doesn't seem to have good support with CQL.
Whoever asked that, I swear I did not make them do that. Yes, we have an awesome driver, the DataStax Java driver. It is in GA. I know it's new and not a lot of people know about it. Use that driver, and our driver has a lot of things in it that you will need. I saw a question say, is it node aware? Of course it's node aware. It does things like CQL. It's actually built around the idea of using CQL. But our drivers, and this is not just the Java drivers, it's the C# driver and the Python driver as well. They also embody these methodologies of failover and clustering and doing things like setting up quorums. All these things are built into it, and they're very, what's the word? They're very friendly to the developer because we've wrapped a lot of things that were somewhat complicated before into easy-to-use frameworks. So go download it today. We need a slide.
Great. That is Patrick Mcfadden public service announcement right there. So interesting on compaction here. I lost it. Hold on one second. Bringing it back. Does compaction scan all the SST tables? Does compaction need to always scan all the SST tables?
No, compaction doesn't scan all the SS tables. Compaction takes the SS tables that need to be compacted and then reads them, merge sorts them, and then writes them out to a new SS table. The only way you would ever do all SS tables in a compaction is if you did a major compaction, meaning that it was a user-initiated compaction. I do not recommend doing that. That is not a good thing to do. There's two other things that will touch every SS table.
By the way, just a clarification, because Wade is clarifying, TTL and SS tables.
No. The TTLs will expire from the application level. You won't see that data whenever you ask for it, and they will naturally expire over time whenever the compaction is run, but it's not deterministic. Now, with 1.2, there are settings there that will trigger what's called the TTL compaction, but only in those specific use cases. It's not something that whenever we run compaction, it just looks at every single SS table. That is not what's going on.
Okay, great. So another one from Chandan, wondering what is preventing two users from not stepping on each other in respect to locking in your form versioning use case?
All right, so there's a couple of things actually. The CAS functionality would be where if you were worried about simultaneous access, the new version 2.0 feature will prevent that. That's using more of a deterministic type lock. What I presented was more of an optimistic lock. There are probably some methods you can do to detect that, and this is meant to be more of a simplistic data model, not into more complicated. We can go into your specific use case if you're worried about that, but really CAS functionality was designed around that. It's like this is an edge case that we need to manage from the database and not the application level. So taking away that complexity from the application.
Jazzbeer is asking, in the log model, if you can go back to that slide, Patrick, the CQL clause has clustering. Clause, please explain that. So please explain the clause that has clustering in it.
Clustering order by?
Yeah.
Okay, clustering order by, again, is how you specify the sort order of the data as it's being created. So an SF table, sorted string table, it stores data on the disk in a sorted fashion. When you use clustering order by, you're specifying that order. So in this case, what I'm doing is I have this date to the minute, which is a bar chart, so it's a date. When I say clustering order by and using that date to minute and using basically reversing that, so instead of ascending order, ASC, I use descending order, what it's doing is it's storing that data in a way that, like what I would call reverse, which means that the last thing that happened would be the first thing on that row. So that it's just some complicated, it's more of a complicated syntax to mean I want to reverse the order of data that's being stored on the disk. Much more efficient. But the key is that it allows for things, select queries just like that, where you say select date to a minute, limit 20. I want the last 20 things that happened.
Thank you. So little clarification here on replication. Maury is asking, in any data center containing 3 nodes but with replication factor 2, does the replication happen clockwise if the topology is in a ring? Say data center 1 is 2 and data center 2 is 2, but each data center itself has 3 nodes. So I think a little clarification on how actually replication works would be good, Patrick.
Well, inside the data center, yes, it's the adjacent nodes, like you said, it's clockwise. But across the data center, the coordinator will communicate with a node in that, just one node in that data center. It does not replicate data to each individual node. So when that coordinator then sends data to the other data center, it talks to a coordinator on the other side, and then that coordinator's job is to replicate it. But it replicates in parallel. It's not one at a time. It's not a serial replication. It does everything in parallel. It's determining the replica pairs is in a clockwise fashion. Maybe that's the combo you're trying to mix together here. When data is actually replicated, when you create it, it's done in parallel. But when you specify the replication pairs or the replication servers, they're done in a clockwise fashion.
Great, thank you. And here from Sal, and I think this is always good clarification because we talk a lot about Apache Hadoop and Apache Cassandra, and Sal's asking, do we need Hadoop to run Cassandra, or are they separate and don't need each other to live?
They are completely separate. They're cousins who talk to each other at the family reunion every once in a while, but they don't need either of each. They exist so independently that there's not even any crossover. For instance, Hadoop is pretty complicated from an ecosystem. It requires name node, job trackers, zookeeper. There's a lot going on there. Cassandra is completely self-contained. There's nothing it needs to run by itself. And you start up Cassandra, that's all you need to start. So there's some integration patterns with DataStax Enterprise that we've created to make the two work well together. And it's just really more glue than anything. And the DataStax Enterprise version of Hadoop will then use Cassandra as a data store instead of HDFS, which then at that point they are pretty inextricably locked, but it's just because we're layering Hadoop on top of Cassandra.
Brilliant. And we have 1 minute. I think we can get through these really fast. So, is there a non-blocking compatible driver available for Java, e.g. one that uses Neo or Netty?
Yes, our Java driver, the DataStax Java driver, I got to say this twice, uses Netty, it uses non-blocking I/O, it uses thread pools and dispatchers. Go download it. Check out I have a presentation from the summit about it. It is awesome. You'll love it. There. Next question, quick.
Eunice asks, what are the recommended ingestion and extraction clients that are available?
Ingestion, boy, you're asking the wrong guy because I like to write my own code for ingestion. But if you have to, if you want to use something off the shelf, I mean, if you're gathering log data, Flume is awesome for that. There's plenty of code out there, example code. If you want to use something like a ETL tool, Pentaho, Talon, they all will take data. With DataStax Enterprise, we also use Scoop. Grabbing data out, again, you can use something like Talon. You can write your own code. We have some utilities on the command line, SS table to JSON. So there's lots of opportunities to get your data out. It's just what do you want to do with it and how do you want it?
Perfect. Great. We are at the top of the hour. Patrick, thank you as always. Everyone, please join us next week for our performance optimization webinar that will be delivered by Al Toby from Uyala. He's had a lot of experience with Cassandra in production, and that is a great presentation.
So I can't even recommend that even more. That's going to be, I'll be watching that one.
So you know it's good.
Oh, yeah.
Thank you very much, Patrick. This has been great. Really appreciate it.